Now that you know what slope is, we're going to talk about how to use it to graph something, especially starting with an equation in what's called slope-intercept form. So when working with slope, it always helps to remember the definition of slope, which is that change in y over change in x. So if you think about slope in that form, the numerator and denominator tell you two separate things. So we can use the slope as the directions between points. So the first thing to remember is then when you have a positive number, that graph is going to be increasing from left to right. So the graph is going to look like it's going uphill. Again, it all comes down to what your numerator represents, that change in y, compared to what your x represents. So in order to make it look like it's going up, you're going to move up for your change in y and right from your change of x. We're going to start with proportional equations, which we know start at the origin. So to graph y equals 2/5 x, my first point is going to be the origin. Then from there, I'm going to use this slope. So looking at this first combination, I'm going to go up 2 and to the right 5. So from my origin, I'm going to go up 2 and right 5 to get my next point, and then do that again until I run out of room. So up 2 and right 5. Now you'll notice that's only half of the graph. So to continue this straight line, I need to now go this direction. So to do that, I'm going to switch and reverse and now go down 2 and left 5, back from the origin. So starting at my origin again, down 2 and left 5, down 2 and left 5. And now I see that I have a nice straight line that I can connect to my points and draw little arrows at the end to show that it technically would go on forever. Next, we're going to look at what to do with a negative. So a negative graph is going to go the other way. So you're going to start by going down and to the right instead of up and to the right. Now, you might be thinking, but wait a minute, there's not a denominator on this slope. So remember, -3 is the same as -3 over 1, and then that way you have both directions to go. So here we're going to go down 3, again, since it's negative, and still to the right 1. So starting at my origin, down 3, right 1, down 3, right 1, down 3, right 1, and then I'm out of room. So then we flip it the other way, and this time we're going to go up 3 and to the left 1. So up 3, left 1 from the origin, again until we run out of room. So then I can connect to my points and draw my arrows at the end. So you'll notice that these two graphs look very different. This is a smaller number, that 2/5, and it's positive, which is why we started by going up and to the right. By comparison, this one was a negative slope, so we went down and to the right. You'll also notice that this one is a little steeper. The reason for that being -3 is a bigger value than something like a fraction of 2/5. So the bigger the number, the steeper that it is. So not all equations are going to start at the origin. And what's going to happen with those is they're going to have a constant at the end of the equation. So let's look at the one we just graphed of y equals 2/5 x. We go up 2 and right 5, up 2 and right 5. So you'll notice that when we do something like add a 5 at the end, it now starts up at +5. You'll also notice that it has the same slope. So up 2 and right 5. If we subtract a number, it gets bumped below the origin. So here it's at -6 to start. But again, since this is still 2/5, it's still going up 2 and right 5. Where a graph hits that y-axis, which is highlighted in this graph below, is called the y-intercept. So there we saw something that had a y-intercept of -6, and we also saw a graph that had a y-intercept of +5. It's also okay for a graph to still start at the origin. There we would say the y-intercept is 0. There's two ways to list the y-intercept. You could list it just by that y value where it hits that axis. So these would be a +5, a 0, and a -6. Or you could list it in its point value. So here it's important to note our x value is 0 since we did not move left or right at all, but the y value is 5. If it's the origin, you could say the y-intercept is 0, 0. And if it's negative, we would want a negative value for our y. So if we look at these graphs and just practicing finding that y-intercept, you're looking for where the graph hits that y-axis. So if we look at this particular one, it's up here at 4, or again, you could say 0, 4. For this one, it's negative, so you would say -4, or again, 0, negative 4. And this one actually hits at the origin, so either 0 or the point 0, 0. Just as a little flashback to something you've heard before, if it hits the origin, it's not only linear, but also proportional. So when graphing equations that have that plus or minus value at the end, the only thing that changes about how you graph them is where you start. So if you don't have a plus or minus constant at the end and it's just y equals number slope times x, you start at the origin. So an example of that would be y equals 2/3 x. There's no plus or minus value at the end, so we started at the origin and then used that slope to figure out where to go next. So 2/3 would be up 2 over 3. So up 2 over 3 until we run out of room, and then switch and go down 2 and left 3. We're still going to use that kind of stair-step motion with the 2/3, but since this has a -5, that's where we're going to start off of the origin. So if it's -5, you're going to move 5 below the origin. But like I said, you're still going to use that slope of 2/3. So from your -5 starting point, I'm going to go up to right 3, up to right 3 until we run out of room, and then switch and go down to left 3, again from that new starting point. So here would be my graph of y equals 2/3 x minus 5. You'll notice it's the same steepness as y equals 2/3 because they have the same slope. Only thing that changes is where to start. Let's look at one more example. So already graphed, we have y equals -4x. And remember, you can think of that as -4 over 1. No constant here, so we started at the origin, went down 4, right 1, down 4, right 1. Here we have a positive y-intercept. So we're going to be starting up at +3. So I moved up off of the origin 3 spaces. Then I'm going to use that same slope of -4 over 1. Since it's negative, we're going to start by going down 4 and right 1, down 4 and right 1, down 4 and right 1. Then we're going to switch and go up 4 and left 1. And I'm out of room. So then I'm going to connect them. And there's my graph. So the first thing to look for when you're graphing a linear equation is there a y-intercept or would it start at the origin? And that all depends on the constant at the end of the equation. So if there is a plus b value, that's where you're going to start. If there isn't one, you're going to start at the origin. From there, it's all the same based on your slope. Positive number, move up and to the right. Negative number, move down and to the right. So just to do 2 more examples here real fast. If I have the equation y equals 3x minus 4, first thing I'm looking for is that y-intercept. So here we're starting down at -4. Then from there, using my slope, here it's 3 or 3 over 1 to give me both directions. So from my starting point, I'm going to go up 3 over 1, up 3 over 1. And you can see once you get the hang of this, it gets pretty quick. Then I'm going to switch down 3, left 1, down 3, left 1. And there's my graph. One more example here, we have y equals -2/3 x plus 2, starting here up at 2, then using my slope of -2/3. Since it's negative, I'm going to drop 2 and go right 3. That's something people mix up at the beginning a lot, so don't feel bad if that happens to you. Then up 2 and left 3, again to give me that decreasing graph that I get from a negative slope. Connecting those at the end, and there you have it. So for slope-intercept form, thing to remember is start at your y-intercept and then use your slope second to get your next points. Good luck.